Yeah. All right. So far away.
All right, so this is the training for SciFinder-n. So basically, SciFinder-n is a database that is very useful if you want to search for information that is related to chemistry. So whether that's organic chemistry, biochemistry, or analytical inorganic, or something even like polymers or super molecules as well. So all of these will be, you will be able to find information on SciFinder. So if you're a new user, SciFinder-n is one of the databases that is available on the library database collection. So if you go, this is our University of Sydney library page, and if you go to database, you can search for SciFinder-n here, or you can also just search it under S as well. So you should be able to go to see SciFinder-n. So we're going to focus on SciFinder-n today. So if you just create a register and create a registration credentials, after that you will be able to log into SciFinder-n. So after you've done that, and you sign in, you should be able to have the landing page for SciFinder-n, which looks like this. So you have your search function on the left-hand side here. So we have reference to search, a substance to search, and also a reaction search. So these are the three main search features that I will be focusing on today. You also have your search bar in the middle as well, where you can type your text searches. You also have the draw tool here for you to draw structures as well, import structure into SciFinder-n to search. On the top left, on the top right, you have the save, so that will have all of your saved searches, and I'll show you how to do how to save searches a bit later as well. You have the history icon as well, so this is everything that you search for is archived indefinitely, so you will be able to go back to your history of your search as well, and that is also available on the landing page, just right on the bottom as well. So what we are going to start off today is start with a references search. So this is very useful if you want to do, for example, a literature search about a topic, for example. So say I have, I want to search a topic about ethanol oxidation, or ethanol fermentation. What I would do is I probably just start with something that's general. So I'll just start with ethanol. So I click search. Oh, just ask me to sign in again. All right. It's been on idle for a bit, so yeah, you shouldn't have that problem. So if I just type in ethanol here, you can see that we have a quite a large result set. So ideally, we would like to tailor this down, filter it down a bit more for us to manage our search a bit better, to do our literature search more efficiently. So in this case, we can start adding other search term into our search as well. And a really good way that you can do that is to use Boolean operator. So that's and, or not. So say if I just start combining keywords together, so and will include two such terms together. So say if I want to learn about fermentation, for example, I can type in fermentation, or I can also just do ferment with an asterisk. And the wildcard asterisk will search for anything that's afterward that is unspecified. So things like fermenting, fermentation, ferments, and all that. I can also want to search for example, oxidize as well. So I can just do that, and the question mark will just replace, taking into account of the US versus UK spelling as well. So the question mark wildcard will just replace 0 to 1 character. Now, if I want to search for just ethanol and I want to exclude the certain other chemicals such as methanol, I can also do that as well. So I just use not, and I should now exclude the search term methanol from my searches. So let's try that again. I should hopefully narrow down our search quite significantly. So we can see that now we have a more manageable result set. So we have about 65,000, and that goes down from about 1 million. So that's good. So this is the interface you will have once you've already composed your search. So on the left-hand side, you have our filter. So that's what we are going to use to strategically to actually narrow it down to say about, for a manageable size, would probably be something like 50 to 100 articles you can realistically go through for a literature search. You also have all of the different functions here, so which we'll come back to in a minute after filtering. And also we have sorting as well, and all of our result is in this corner here. So there's a few options for us to filter that our result. We have document type. So that's the first one. For a literature search, we probably would like to look at something like a journal article or also a review article as well. So let's just select those two for now. The next filter is the substance row. So what this does is it will filter out the indexed row of the different chemical compounds that are available in these references. So say I want compounds that participate as a reactant or reagent in these references, or I also want to look for something like an analytical compounds that are used in an analytical study. So I can do that as well. So I'll just select these two. So that will just exclude all of the other rows of chemicals. So SciFinder-n also index references that are in other languages as well. So if you happen to read another language, you can also do that as well. But most of the articles or references should be translated to English. So in this case, I'm just going to select English here. And the next useful filter is actually the year. So if your literature search, you want to search in a particular time period. So I want something, for example, just the most recent year for relevance. I can do that as well. So I'll just select, in this case, the most recent 20 years. Or if you want to search for something that's more history oriented, for example, in a time frame or in a decade, particular decade, you can do that. So just by limiting the publication year filter of your search. Now, one new feature of SciFinder-n that you might not have come across if you were a SciFinder user, this is the concept. So what this does is if you select this filter here, concepts are basically topics, main topics that are indexed within these references. So it's been manually indexed out, which kind of like give an overview of what the reference is about. So sometimes the index concepts will give you a topic that your regular searches will not pick up in the titles, abstract, or keyword section of your search results. So this just give you, the concepts basically give you the topic, and it gives you more relevant results. And apart from what we have in our original searches, is fermentation, ethanol, things like that. I'm just going to select the field as an example. Right here, you see that there's also other things such as like a different type of fermentation, oxidation, the different spectroscopic technique as well, and the different uses, so like food processing, beverages. So you can actually really quickly see an overview of what are the topics that are related to your search as well. So if you not sure about the direction where you want to take your literature search, looking at the concept section will also be a good idea as well. And you also can search for a particular concept as well. Say if I want to do to know about enzyme or enzymatic process, I can also do that as well. So I'm just going to do enzyme with an asterisk. So all of the search fields in SciFinder-n, you can use wildcard and Boolean operators to help you with composing your search as well. So right here we have enzymes. You can see apart from just pulling up enzymes, it also pull up all of the related topics or idea about enzyme as well. So I'm just going to pick a few of these. So just as example, you can see we have now selected 14 different concepts or related topics to narrow down our search a bit further as well. Okay, so the next filter is the database. So SciFinder-n catalogs references from both the CA+ and also the Medline databases as well. So CA+ will have more references or information regarding to things that are chemistry oriented, whereas Medline will be more on the side of medicinal chemistry, biomolecules and all that. So it's good that we have both of these databases in SciFinder-n. And the new thing about SciFinder-n that SciFinder did not have is if a reference is a duplicate in both of the CA+ and the Medline database, now that reference will be merged into just one search result. As usually before you have to manually merge that, but you don't have to do that anymore. So say if I just want a Medline, I can do that. Just select Medline. And finally, if you still want to narrow your search down a bit further and you've already gone through all of the other filter, you can actually just select a particular term or particular idea that you want to search as well. So you can also search within the result or search within a search as well. So if I want to search about a fermentation in the context of, the starting materials is a rice or some fruits, I can do that as well. So I can just do click find. And you can see that we've started from about just under a million searches results. Now we've narrowed it down to a much more manageable and more realistic result set that we can go ahead and select references now, so we can do our literature search. And you can do that by selecting just individual references that you find are the most relevant, or you can just select all of them at once as well, just by clicking on these. Now you also have the option to search for all of the substances or chemicals within these 27 results as well, for example, or you can also search for reaction or these results as well. So the three types of searches in SciFinder-n are now interlinked here, so you can really quickly jump in between these three different modes as well. And you can also do the same thing with your main search as well, just by selecting different types of search from here and change it to a new one. So if we want to say, if I want to have a look at this articles here, I'll just click on here. We should have a reference detail. So the reference detail will have all of the, just the titles, authors, all of the normal, regular details. Down here, you also have the concepts, which I mentioned before, as the topic that I indexed out in this particular articles. You also have the Medline subject headings as well. So your search will now search for both of these kind of headings within a reference as well. And you have references, so substances. So all of these are molecules or compounds that are mentioned in these references. And you can see when I mentioned before the substance role, so that's also manually, somebody has already indexed this out, the role of say ethanol in this particular paper as well, which will return the search if you do filter it in that way. And within each of these reference, you can also get the full text as well. So if you click on full text and go to click on our university link, which should take us back to the resources at our own university. So you can actually have a look at that as a PDF, or you can order it to view it as well. One more feature that is added into SciFinder-n is the citation map. So if you click on citation map, you can very quickly look for related references or articles that are relevant to what you're searching. So this is our articles, and on here on the purple columns, all of these are references that this document cites. So that's just mean the bibliography of this particular reference. But you also have on the blue side, you have referencing that are citing this document as well. So this document as a bibliography item in other articles as well. So you can very quickly go through these because each of them also have a citation map themselves as well. So you can very quickly go to get more related articles to the one that you like as well. And you still have the option to filter by concepts as well. So all of the citation map in here, you can also filter via concepts to get more quickly get more relevant results as well. And a new thing that you have for SciFinder-n is actually the ability to open multiple SciFinder-n tab now. So before you were only able to, in SciFinder, you're only able to do one tab at a time. So you now can now open multiple tabs. So it's a lot more convenient. It does not give you an error every time you try to open SciFinder in a new tab. It's SciFinder-n in a new tab. So the sorting right now is currently set at relevance, which means that it's a special algorithm of SciFinder-n that takes into account of your search terms, so what you enter in here as a search, and how that search how those terms are meshed with the title, with the abstract keywords, concepts, and headings, and also how well cited the reference or document is as well. But you also have the more traditional sorting, such as the citations, or how impactful that particular reference is. So you can also have publication dates as well. So after you've already selected all of your preferred references, you can actually download your search, your results set. So you can just give it a name here. So the download icon is on the top right here. So you can give it a name. Now you have a different option to a few different options to actually save it as. So you can save it as a citation, or this would be good for bibliography manager such as EndNotes. You can also save it as just a PDF, or you can save it as an Excel file. And the benefit of saving it as an Excel file over PDF is actually you can sort the different columns in your Excel spreadsheet. So you save it in this way. Yeah, so once you're happy with that, you can just click download. You can also share this result set with yourself or with someone else as well, just by typing, just click on the mail icon here and just type in your or someone else's email address as well. And you can also save it as well. So you can just give this result set a name, and then you can tag it, or you can just put a new tag on it with a color. So that just help with sorting as well. And you can also let SciFinder-n give you alerts if there's any new references or new result turns up as well. So if you see, I've already tried a few different tags here. So once that you save this, it will go into the star icon on the top right here, which you can access it at anywhere on SciFinder. And if you happen to forget to save your results, remember that it's always be in the history. So if you click on history, it should take you to your search here as well. And yeah, so let's try a different search here. So if I want to do cytochrome P45, so this is a protein in fungi and parasite, and usually are a drug target as well. So if I want to, in particular, know about fungi or parasite, I can do this. So just quickly type in my prepared search here. So if I click search, and say that we have a new result set here in a moment, if my internet is fast enough. There we go. So yeah, again, you have all of your filter available, but there's one thing that I'd like to point out that I haven't covered yet in the reference search is actually patterns. So if you select patterns, sometimes you will also get more information about how a molecule is made, how it's a patent, where it's something. If you want to compare what you have on hand, so like a patent, say whether it's novel or something made before, you can use the patent filter here as well. So within these references, you will have patent pack here, and you select on here, you will see there's a few different options that you can view these patents. So I'll start with viewer. This is the most interactive version of this pattern viewing. So you see on the left-hand side, you have all of the reference or indexed molecules I already pulled out here for you with the page that are bookmarked as well. I'll just give that a moment. So you can see here, this is our pattern. And if you go and you select one of these, just basically click on the page, you should be able to get to, it will link back to where that molecule is mentioned. So you can see here. So you can also click on here on the pattern bookmark, and it will also link back to the molecule as well. So you can very quickly search for the substance or the molecule of your choice as well. And the other version, slightly less interactive version of this, is a PDF plus, which is a PDF version of this, and there's also a table of index compounds at the end of the PDF as well, just to help you really quickly find out where your desired substance is as well. I'll just give that a moment. So you can see here, that's the same pattern. And if you go scroll towards the end, so you can see that this table here are all of the indexed substances that are in this pattern as well, with the linking back to the page and where you can find it as well. So that's also quite useful. So that's pattern pack. Now there's one more option that you can use, and this is the advanced search. And it is only available if you select in specifically for references. So if you search for all, it actually will search for all 4 of these searches at once. So the search engine is a lot more powerful now than SciFinder was before. However, if you want more functionality for your search, I do recommend that you use these one in particular. It just allows you to actually tailor your search a bit more. So if I want to search for a particular author, I can go into advanced search. So the advanced reference search option will give you the ability to search for a particular author, a particular journal, or a particular organization as well. So say if I want to search for a particular author here, so Peter Rutledge, for example, I can do that. So I can just search with that. So if I want to combine that with something like his article, but from a particular journal as well. So J. Metcalf, and is from our university. So I can also search for the University of Sydney as well. You can see if I click search now, it will return to me the result of Peter Rutledge from our university, from this journal as well. So that is mostly the overview of the functionality of a references search. And the next search that I'd like to cover is the substances search. So this is for when you want to search for a particular molecule of interest, you want to see more details of that substance or molecule, and you want to also search for molecules or compounds that are similar or are related to that molecule as well. So you still have the option to search by name. So apart from the actual name, you can also search for things like the different variation of the chemical name spelling. You can search, if it's a medicine or a drug, you can search for the generic or brand name. It will also return the same molecule as well. Say if I want paracetamol, let me just do that here. And we'll come back to the drawing structure function in a little bit as well. But let's start with just the name now. So you can see now it will, if you search by text, it will only return the one, so the actual molecule, and no related substances or molecule to this one. you still have the linking back to all of the references that mention paracetamol and all of the reaction that are indexed as well as the suppliers. If you click on the molecule, you will have this pattern here where there's a bit more things for you to select from. You can, so we'll come back to reactions and retrosynthesis in a moment. We'll also come back to the edit or the drawing function in a moment as well. But right now, let's focus on the substance detail, which is here. So if you click on here, it will take you to the detail of all of the details of this substance. So right now, just right here is just like an overview of this molecule. So you have your structure. You also have the key properties here listed out for you. But if you go down a bit further, your first thing you have is like all of the names identifiers. So if you search for any of these names, including the SMILES shortcut here, so all of these 167 synonyms here, it will actually be able to return you this molecule as well. So that's also quite useful. Now you also have the experimental properties and spectra that are available here. So if you click on here, all of these chemical, biological, and physical properties will be here, listed here for you. And also there's references as well. So if you want to reference this in your bibliography for something like a report or a thesis, that would be really easy to do with this. So if I want to know, for example, a melting point range, I can just go to the thermal tab, and you go down to melting point, and you can just pick the range that relevant to what you're doing. And there's also references as well. So if you click on the reference, it should take you to number 15 here, which is where that value comes from as well. Let's go back up a bit. Now, the next tab is the experimental spectra. So these are all of the spectroscopic data for your paracetamol compound. So you have things like NMRs of both of the proton carbons. You have things like IR, mass spec, UV-vis, X-rays. All of that are here for you. So if I click on one of the proton NMR spectrum, you see that now you can view that spectrum here to compare it to what you have on hand, and there's also extra detail down here, such as the strength of these magnetic field and also the NMR solvent that was used as well. So let's get back. Now, sometimes if your compounds are not very well documented or something a bit more obscure or novel, for example, you might not necessarily have all of the experimental data. In that case, you can, next best thing is actually to use the predicted property and also predicted spectra as well, which are available here for you. If your compounds or substance is there is biological activities or biologically relevance, you also see bioactivity indicators and target indicators as well. So what bioactivity indicators does is all of these are concepts that are in the references. So those are the concepts or topics that I mentioned before in the references search. And say if I click on, for example, anti-HCV agents, that means that there are 80 references that have the molecule, paracetamol, and the concept or the topics of anti-HCV agents. Now, what bioactivity indicators do not imply is it does not say that paracetamol is an anti-HCV agent. It just say that there are references or probably there's research going on about anti-HCV agents that uses paracetamol. So if you want to, learn a bit more about what your molecule or compounds might be, what application it might have, a very good way to do that is just to look through the bioactivity indicators here. Now, so as I mentioned before, when you go back here, if you search for the text here, search for paracetamol via text, you only have one substance. But for practical use, you normally would also like to see the related compounds to this as well. And the way that you can do that is actually to import, to kind of get this into the drawing tool. And you can very quickly do that by just click on the molecule. And if you click on edit structure, it should take that into this drawing tool, which is on top here. So let's do that. And then edit. So that now goes in here. Obviously, you can still just draw it out yourself if it is an easy, quick molecule. On top here, you also have the option to just paste in the CAS number, the CAS number, or the smart strings as well. And then that will import the structure in for you. And I'll show you an example of that in a moment. So you do have an option to use CAS draw or ChemDoodle. We'll just stick with the CAS draw here because I think this is the more popular. So at the bottom, you still have your just your basic, your general structure drawing tools here, where you can just do bonds and do common atoms here. But you also have the option to just pick any atoms that you like. So this is just your periodic table, or you can also use shortcuts right here. So these are mostly just functional groups, or you can use variables, so just any halogen, any metal, or you can just use the R group function here, which will combine all three together if you wish as well. So say if I just want my R group to be a proton, or hydrogen, or any halogen, or a methyl group, I can do that as well. So if I click that now, this R group here represents all three of those that I just selected. Now I can just draw back the bond here into one of these just to modify my search a little bit, but I can also do a variable bond. So say if I want to, I don't care whether it is on the ring, I can just drag from the atom back into the carbon where I want it to be. So say right now, what I'm telling SciFinder-n is I just want it on the ring. I don't really care where it is. So that's one useful way that you can modify your search. You still also have the lock option here as well. What it does is say if you click on lock atom, and if I lock this carbon here, so that's now a rectangle around the carbon, and I lock the oxygen here. So what it does, it will prevent SciFinder-n from search for, when I search for related compound, it won't search for anything that extend beyond the oxygen or extend beyond the carbon. And it will instead just extend out in these other bits in the middle here as well. Now, if you use SciFinder in the past, you would notice that when you want to do a substances search or a reaction search, you have to do that either or. But right now, you do have the option to also use a reaction search in here as well. So all of the reaction tools are down the bottom here. So that's one more thing that just make the drawing tools a lot more user-friendly as well. Let's click OK. So now we have our modified search. So now if you start to search for this, and just click on the magnifying glass or hit enter. You should see that we now have a much broader result set that have more related compounds here. So there's three functions. So we have as drawn, we have substructure, and we also have similarities as well. So this is also something new in SciFinder-n. In the past, you actually have to search for either one of these three in SciFinder, and you have to actually go back and switch in between these different types of search. So now SciFinder-n is able to search for all three at once, and you can cycle in between them much more easily. As drawn is actually, it will search for results that are specified by you in the drawing tools before, and just those results. So you can say that whatever is highlighted in blue are actually what I specify. It will also search for what I specify as part of a multi-component substance as well. So, for example, if I take a look here, this substance may have two components. So the actual what I search, and also the other component, which is the salt, corresponding salt as well. So it will actually count that as a hit as well. It will also search for the different isotope of your atoms. It search for charge or charged compounds, ions, or radicals as well. It will also search for, if you're searching for polymers, it will search for the monomer of that polymers as well. And it will also take into account the tautomers or zwitterions as well. So that's what the as-drawn function is. So this first one right here. And you still have all of the filter that you can to actually do the narrowing down of your search as well. Such as, do you want this to be a product or reactant? You can do that as well. Now, here we have reference row, which is sort of like the same idea of when you were searching for in the references section, and you have substance row. So this is the same thing as that. So it will narrow down the compounds based on the indexation of what it does in a particular reference as well. So number of components is something that is new in SciFinder-n. So you have now able to specifically narrow down to, do I want something that looks like this, so there's multiple components, or do I just want a single component or just a single compound like this? So you can do that as well. Substance class, this one right here, this filter, will actually narrow down or filter down to the type of molecule that you're interested in. So something like a polymer or something such as just a coordination compound right here, for example. So depending on your need, you will be able to narrow down the type of molecules as well. And there's still all of the other different information that you can also do your narrowing down as well. And you can also do draw a particular motif or part of the molecule, and then in here, and then that will search for that particular structure or motif within this result set as well. Now, if I go back to the top, if you find that you don't have a lot of example that you're looking for, you can also expand the search out a bit more using the substructure. So now what this does is actually it will search for your specified structure. So the one in blue here as part of a larger molecule. So right now I'm still on relevance. So that's why the most relevant is still on top here. But if I switch to a different kind of sorting, so if I want to search for a very big molecule, then it will become much more apparent that now my search is my specified structure. And you can see here. Now it is part of a much larger molecule here. So you can see the specified bit is in the kind of like in the middle right here. But because remember when I was inputting the search into the drawing tools, I locked the atom on either, locked the carbon and oxygen on either side. That prevents SciFinder from expanding into those locked direction, and only expanding in the non-locked direction. So that's one way you can really quickly search related molecules or substances with more control as well. Now let's see, next part. Yeah, so you do have an option to do an advanced search in substances. And what that allows you to do is to just type in a molecular formula, substance properties. So those are the different chemical, physical, and biological property that we have here. You can also do a filtering later as well. I think that probably be a bit more convenient than this. You can also have the option to now input a particular peak of an experimental spectrum as well. So we don't, SciFinder-n does not have the option for you to upload your spectroscopic spectra for comparison just yet. So right now you just can only do it with NMR, and you can only do just input in a peak right now. But this is, say if I want to search for nylon, for example, so polymer, and I have its chemical formula on hand because I've only prepared for this. So if I just search for this here, so this is the monomer of my nylon. So if I click search, I should be able to, using the advanced searching for a particular substance using molecular formulas as well, as you can see here. So I have all of our different nylon polymer here. So that is most of the function that are available for in a substances search. And the third search that I'll be covering today is the reaction search. So in this case, you have a particular compound or a particular molecule that you like to make, or if you want to know what it can do, and what kind of reaction available there for you to look at. So you can do a reaction search here. So you can obviously draw out your reaction itself as well using the drawing tool and the reaction tool here that are available. You can also just type out the actual molecule name. So say if I do a ketoconazole, this is an antifungal. And if I click on for search in the reaction tab, I should be able to get all of my reaction out here as well. So SciFinder-n also understand context as well. So if you say synthesis of ketoconazole, it will actually search for ketoconazole as a product. So it will exclude out the search where ketoconazole is a reactant as well. So it does understand the context, but I'll just stick with ketoconazole for now. So this is our reaction search result set. You can see that right now the reactions are grouped by scheme. So say there's scheme 1 here. So this is this particular type of reaction here. There's 7 different reactions. So there's 7 different references that contain this reaction here. So it's grouped by this way. So it just makes your searching a lot more efficient. So before in SciFinder, you actually have to look for one reaction, and then you have to actually manually go down to look for a similar scheme to this, but with a different condition. So right now, all of the different conditions are grouped under the one scheme. So it's like, if I try the first one, it doesn't work, I'll try the next one, until there's something that works for me. So again, it just makes it a lot more intuitive and more user-friendly to use as well. So we have substance role, we have use. So all of these are kind of straightforward. There's a few that I'd like to point out that will be quite useful. So first one is the non-participating functional group. We also have experimental protocols, and we also have reaction notes here as well. And obviously, there's all of the other filters, and feel free to, when you need to do your search, just try it out yourself as well and see what you come up with. Now, the first one, non-participating functional group. What this does, if you select on any of these filter here, the functional group that are selected will be preserved in the reaction. So the starting material and the product will contain that functional group, and it won't be degraded, it won't be changed in the reaction. So it's very good if you have sensitive functional groups, so it's especially for more larger molecules as well. You have multiple sensitive functional group. Usually what will happen is you have to do a protecting step. So you have to protect that functional group, and you actually have to do an extra reaction where you have to deprotect that group as well. And if you click on this and it does show you the result, then that particular functional group is fine for that reaction condition. So it saves you 2 steps of reaction. Now the reaction notes are actually notes in the reaction detail that are available in these references here. And what that does is just give you the different type of reaction that are indexed out for you as well. So if you want to know about a particular type of reaction, say I want to know about light sensitive reaction, for instance, a reaction in the dark, or if I want to know reaction with high selectivity, so I can do that as well, so say stereo or regio selective as well. We can choose here. And this here is useful for when you want to actually use the reaction conditions, and you want to use the method that I mentioned for this reaction here. So if I click on both of these, now it will return results that contain a synthetic procedure for you to follow as well. Now I'll show you what I mean. So say you have all of these different reactions here grouped by scheme. Go down a bit further. I found one that works before. So something like this. So I have this reaction here. If I click on view reaction detail, you can see on top here you have the reaction summary, so the scheme itself, and also the reaction condition as an overall step as well. But you scroll down a bit further, you now have the methods now, which contain everything you would need to do this reaction in a step-by-step guide. So you have your starting material, you have your reagent, solvent, reaction condition, and step-by-step procedure. So somebody's from CAS has already manually indexed this out from the reference that are in here for you. And they also index out the characterization data for you to compare your substance with as well. So say once you made it, you'll actually very quickly go for that to view it. Now some reaction does have the traditional version of the procedure. So this is just straight out from the reference without any modification. So, and then this is just one step further. Somebody has indexed this out as well. Okay, so, and the new thing with SciFinder-n in this case is also with the methods now. So this procedure here, so in SciFinder, you only have You can only use methods now 5 times and it will run out. In SciFinder-n, methods now is now unlimited, so you can view this for as many times as you like as well. So let's go back to the other one. Now, if you click on any of these molecules, you will still have the substances details and all of the other things that are available before in your substance search. Now, what you would ideally want to do, say if you have such a large molecule like this, obviously a one-step reaction is not sufficient for that. So what we'd like to do is actually look at creating a retrosynthesis plan. So what it is it will lay out the whole plan for you from the end product all the way back to a reasonable starting point as well. So that's what we'll do, but we'll try with a different molecule that I prepared so that it will. Let's start my live demonstration. So this is taxol. So this is another medicinal chemistry molecule. So if I search for a reaction, actually I'll search for a substance. So I can go into that retrosynthesis. So I'll switch to substance and search. So we have taxol here. And you click on create a synthesis plant here. That should take us to the retrosynthesis section of our search. Obviously you can still draw it and everything. So the drawing tool is always there, but sometimes it's just a bit easier if you already, the molecule is too complicated. It's faster if you can just import it directly in there. So depending on how complicated your molecules are, it might take, it might be instant, or it might take a couple of hours to, however many hours, because SciFinder-n will go through all of the index reaction that are available in the catalog. So if your compound is very complicated, it will take a while. So in that case, you can go, just leave it in the background and do something else, and it will do it. And then it will actually send you an email notification when the retrosynthesis is complete. And once that is completed, also go back to your history as well. So you can actually view it on the history here. So right now it's like generating plan, so all of the details not quite there yet. But I've already run this earlier and I've saved it here. So if I go to save, and if I search for, so you can see this is what save searches look like. And you can just click for training. So I've saved it in this particular tag and I can go to the plan. So this one's already completed. It's going to open this plan here. So that's the same thing as the one that is currently being generated. Okay, so let's go to here. So you can see here, this is our full retrosynthesis plan from kind of like the starting point to all the way towards a starting reaction. So you can see here, if I zoom in a little bit, this is our endpoint here. This is what we want. And then start to break down that molecule via many different reactions. And you can see that the retrosynthesis plan also understands that some reaction as selectivity as well, stereoselectivity, and some are just general reactions. So there's two different icons to notify you of that as well. And you can see all of these are now purple, which means they're experimental data. So somebody has already done this exact these exact reactions are reported in the literature. So that's purple. Now, sometime I will give you an example of this as well, about predicted reaction retrosynthesis route as well. So this is when you have a novel or a more obscure, less studied molecule. In this case, SciFinder-n will give you the predicted reaction. And what I mean by that is a reaction of a similar type of compound with evidences in the literature as well. So if you go to plan option, which is here, you also have an option, a way to edit your plan as well. So just more customization. First one is synthetic depth. So how far back do you want your retrosynthesis to go? So for more complicated molecule like this, it will be best if you go a bit more in depth, to say like a 3 or a 4 depth. As you can see here, there's a little thing that explained for you right here. For predicted reaction rate, you do have 3 different options. You have the common rule, so these are most robust. These are reaction or references that are indexed as most robust. So a lot of people have done this. There's a lot of results in the literature. Can be highly trusted, but sometimes when that doesn't give you a lot of result, what you can do is to move on to the more uncommon or the rare rules as well. So just give you more way to explore how you can make this molecule here. You do have an option to protect a particular part of the molecule that you don't want to be broken down in the retrosynthesis plan. So if I want to protect this particular ring here, I can just highlight that in red here, so protect bond, and then just click on those. So that will be protected. And if I want to specifically break down a bond in the retrosynthesis plan, so if I want to break that bond right there, I can just select break bond, and then I click here, and now that will actually look specifically for way to break that bond down in my retrosynthesis plan as well. Let's go back to here. So we do have a few more tabs that you can use to filter out your or interact with your result as well. The next one is all of the steps. So these are all of the steps in the list format. So it will actually link back to where it is on the plan as well, as you can see. And they are linked together. So you click on any one of these, it's the same thing as that one. So if I click on the one in the middle here, so this one here, that's the first one. You can see that there's alternative steps as well. So if you're not happy with what you're given in the plan, in this case, there's about 81 other references that can point you to some other reaction route that you can choose as well. I'll just click that moment, so you can see there's 81 different reactions that you can choose from if you're not happy with what you're given. So this is the one that is given to you. So there's 6 references or 6 pieces of evidence in the literature that this reaction works here as this particular U. But you're not happy with that, you can obviously just pick a different one. For example, say if I just click on this one, for example. Now your plan will be updated to what you just selected. And you can do that with all of the other steps as well. And just give that a moment. As you can see now, your reaction retrosynthesis plan has been updated right here. Now, still loading. So something like that, for example. Now the final section, which is scoring. These are all of the more way that you can use to filter out your results. So ideally, you want all of these filters to the adjustment to be all the way towards the right. So you want a maximum amount of complexity reduction. You want a maximum amount of convergence. And convergence just mean how when you go back, how diverging it is. So it's not a linear chain of synthesis, because that would make it really inefficient and it would give you low yield, whereas more branching or more convergence here will actually make you your reaction more efficient as well. So you also want the maximum amount of evidence. So you want a lot of references in the literature that already cite this reaction, so it's more reliable. Obviously, you want the highest yield possible, and you also want your atom efficiency to be quite high, so you don't want to waste a lot of material during your process of making these compounds as well. It's not always possible to actually just have everything towards the right. Right now, it's still kind of updating that plan that I selected before, so I can't actually slide it yet. But sometimes when you don't have a lot of result for your retrosynthesis plan, a good way to do is just to get more result, just to tweak this a little bit. So make some compromises just to give you a reasonable plan to work with as well. So that is a retrosynthesis plan for a well-known molecule. But some instances when you want to make a novel molecule, and I'll give you an example of that right here. So all of the purple reaction here, all of the known reaction might not be possible. So in that case, I'll just give a different So say if I have this compound, and here I'll also show you how to actually do importing of your a particular compound into SciFinder as well. So say right now, ChemDraw, if you have ChemDraw, it is integrated into SciFinder-n as well. So say if I want to have this molecule here, I just highlight it and I can actually just import it directly into SciFinder right here with this search. Just slow that down a bit. And if I select substances, so I can actually search for any of the previous three that I mentioned. So say if I want to search for references, I can do that. So it has to be ChemDraw 19, so the latest version of ChemDraw, which I think if you are from our university and you use ChemDraw, you will have to update it to the latest version already on the 17th of October this year. So that's all good. Oh, it just asked me to do my password again. Okay, let's go. Okay, so now I've imported my structure into SciFinder from ChemDraw, as you can see here. So now I just search for my stuff here, and I'll close that as well. Now search for that compound in ChemDraw, so you can see that's a quick import of that. You can also, as I mentioned before, do a, let's just move that down a bit. Also search for by CS numbers or CAS number. It will just actually give me the same thing. So let's go back to here and substance draw. So I can also just import a CAS number here, and that would give me this structure. Or I can also use a small string as well. So there's multiple ways that you can import a structure in. And so try up small string, it will also work as just paste it into this search bar on top here, and it will convert it into the structure for you, as you can see. And you also have an option to actually import a structure in as well, so it has to be in the CXF or the mol format here. So it's just two format for now, but there's other options you can see previously of how you can do that as well. So that's how we input this molecule in. So let's rerun my search here. Actually, I'll move it into here, which is what I have before. Rerun search. You can see we have this molecule here. So this one's a bit more obscure, so there's not a lot of references that cite this particular molecule here. So if you click create retrosynthesis plan, you'll be able to look at the plan for this again. So I've already prepared that one earlier as well, just to save time, because it does take, for this one, I think it took like overnight for this result to come back to me. So I won't let you wait for 8 hours, and instead just get it right away for you. So you can see right now, our prediction is on, as you can see. So we start off, our starting material easy, well documented, as you can see with the purple reaction here. But as soon as we get to the more challenging final steps, you can see right here, there's not a lot of references that cite this exact molecule. So you can see there's suggestion, which is in light green here that you can see. If you click on one of these, you should also still be able to look for alternative steps as well. And you can see right here, so it's say the prediction, the one that was selected, has a lot of evidences actually. So just over 150,000 evidence of reaction that are similar to what we're looking at right here. So we know that there's still quite a reliable steps. And if you're not happy, you can obviously still change it to a different selection as well. So that is what you would do. or how SciFinder can actually help you with creating a plan where the molecule is more, is new, is obscured, or is less well studied as well. So I think that is all of the different features, main feature that we have for SciFinder-n. So that's, yeah. So when you have time, you can obviously have a go and try it for yourself as well.
Cool. That was really good.
Yeah.
I've got one question that I thought of while you were going through. When you share the search results, does that also share the search strategy or just the results?
It should share the like the strategies. So it's like all of your filters should still be there, and I think on all of your selections should still be there.
Okay.
What I find is the history might not save that. So like if you just go to the history icon, it would just save your search term. But I think any like save, share, or download should preserve all of them, your other filter as well.
Okay, cool. And I'm pretty sure that it does, but the history is persistent across login sessions, isn't it? It's not just for that session.
Yes.
Yeah.
So actually from before, when I was doing the ChemDraw import into SciFinder, that was from a different browser. So I actually imported into Safari, whereas
cool.
my main presentation so far has been on Chrome. So it's actually linked across as well. So it should be okay.
Yep, fantastic.
Some users might find that their history might not be updated, and that is an ICT problem. I personally had that before. So if someone notices that their history is not updating, it's advised that just contact ICT and they'll sort it out with SciFinder and people as well.
Okay, cool. All right, I'll stop the recording there then.